Hello, everyone, to the session about infrastructure-agnostic continuous delivery. Let me quickly share my screen before we get started. Okay, my name is Oliver Nocon. I am with SAP. Before we get started with the session, maybe a few words about myself. I've been with the company for around about 20 years, a bit more than 20 years, in various roles, initially supporting mainly our consulting organization with respect to custom projects, and then moving into the development organization of the applications, and now more and more supporting development teams on their journey into the cloud. When I'm not at work, I'm with my family, my wife and my 2 kids, or especially in the summer, I'm at the lake and doing some wakeboarding. Maybe a few words about SAP. I guess most of you know what SAP is, have heard about SAP. Therefore, I just brought some facts. Maybe you're interested in the numbers about chocolate or beer. Many of our customers produce together the majority of chocolate, which is available within all across the world. Same applies for beer, for cars, and the like. Now, let's get started. Maybe you know that guy, right? His name is Jenkins. He's been an excellent servant for many of us over the past years, many years. But also Jenkins is evolving. Within SAP are, I have to admit, a very big Jenkins shop. We've been using Jenkins all over the area where I am working in. We provide to development teams more than 1,500 Jenkins instances to individual development teams. And that's not all the Jenkins usage we have within the company. And I guess that's pretty similar in many others. That means we build a lot on Jenkins. To switch context a bit, I don't want to bore you with the state of DevOps reports. I guess most of you have heard about it, but just to set the stage for the things which will follow. The state of DevOps report, especially in 2019, differentiated essentially the good, the bad, and the ugly when it comes to software delivery performance, while the good ones are the elite performers. On the other end, you have the low performers. The elite performers really show off, right? They do have more than 200 times more frequent code deployments. They do have much faster lead time from commit to deploy. On the other side, we all know things don't go well all the time, right? There will be things going wrong, and in the end, we can have the best quality processes in the world. There will always be something which will break. Now, and that's exactly where the elite performers really show off, right? They have an impressive number of 2,604 times faster time to recover when something really goes wrong. And in addition, looking at their quality processes, we see 7 times lower change failure rates. Now, is this about Jenkins? Is this about tools? Not really, right? In the end, what the research shows, it's about development culture. And the development culture is mainly about empowering teams. We have empowered teams at the core. Having those empowered teams, combining them with trunk-based development, that means pushing into mainline at least once per day without having feature branches, release branches sitting all around. Really have one code branch, bringing that out into production and fixing forward, typically. In addition, it comes with a loosely coupled architecture. I wouldn't say we need to have a microservice architecture. The architectures should support the empowered teams. In many cases, it's a microservice architecture. It can be a pretty good componentized architecture as well. It has to support the autonomy of your teams, that your teams are empowered. For sure, we need to have a very high degree of test automation, test things very early, intensively, but again, not everything can be tested, right? There will be also things which you may just find out in production. And the research also shows very strong focus on shifting left on security. Now, taking this into consideration, within SAP, we started many years back a project called Piper. Essentially, from today's perspective, to bring the development teams into this elite group. You may know the company is by now almost 50 years old. Next year we turn 50. Therefore, we have a huge variety of software products, being on-prem, being in the cloud, and the like, right? And in the end, we want to bring the development teams, and we want to help also other development teams outside of SAP, being customers, partners, or anybody out there, to join this elite group for software delivery performance. And there we brought in Piper, right? I don't call it a tool. It's helping teams to move into this elite group, or to work in an excellent manner, especially in the cloud world. We started it off as a collaborative project SAP internally, in a source project, but we very soon turned it into an open source project. We open sourced it towards the end of 2017, and it's been open source ever since. SAP internally, we use this open source project very extensively, and we use the master version of it. We don't use any previous version. We always use the master. Also there with Project Piper, we try to embrace cloud development methodologies and really do more or less trunk-based like development as it is possible with an open source project and a GitHub workflow. But always essentially use the latest version. And that's what most of our development teams, SAP internally, do as well. Therefore, we essentially separate it into something which is open source, which is connecting to systems everybody has access to, while we still keep a small number of things inner source, which essentially is very SAP specific, connecting to SAP proprietary systems and the like. Now, what is it? I typically say Piper is shared coded or shared codified knowledge, which is ready to use. That comes back to this. I don't consider it as a tool, right? It's in the end, for me, it's knowledge, which we bring to development teams that they can easily consume in order to improve on their daily work and focus on the essence, which is bringing valuable software to our customers and not dealing with the nitty-gritty details of continuous delivery flow and so on. Right? That's why we bring these, what we call ready-made pipelines, as a top layer within Piper to our users. The ready-made pipeline is essentially a continuous deployment pipeline from code commit to deploy, including the various aspects of checking functional correctness, checking security, checking also IP compliance. In our case, IP compliance is also very relevant. For many companies it is, and performance and so on, various other aspects. It's all built in this ready-made pipeline. We'll have a closer look at that in a minute. The ready-made pipelines, they compose Piper steps out of the Piper step library. These Piper steps are the integration points to the various systems, to a build system, to a test system, to deploy into certain production landscape, and so on. This integration is done via a step library. And underneath, we do have a common configuration layer. One configuration file, which serves the steps, which serves the overall pipeline, the stages. We'll look into that now. How you get started. On top, you see these kind of ready-made pipeline. With an initialization, there's a pull request voting built in, building, testing, security checking, performance, compliance, and possibly also confirmation steps, since not every team wants to go deploy continuous deployment from the very beginning. They may want to do continuous delivery and have a manual decision when to deploy. Right? The easiest way to get started is take a Jenkins script. I said we started with Jenkins, and that's still the majority of use cases we have. Include the Piper library. There's a Piper library wrapping the pipeline, the ready-made pipeline, as well as the steps. Therefore, 2 lines of code. Include the Jenkins, include the Piper library, the reference to the library, which needs to be configured in your Jenkins for sure, and execute Piper pipeline. That's it. Next to it, you have a config file. For a simple pull request voting in the configuration, you will just tell Piper, in this case, to pick the build tool npm. That's it. You don't need to think about npm install, what have you, npm test. That's all baked in. Therefore, very important to mention, we do a rather strict separation of the flow logic, which is the pipeline script, and the configuration. If we look into that a bit more detail, you see we have the flow logic, the pipeline script, which is essentially provided. A team does not need to deal with it any longer, doesn't need to think about how to orchestrate these various bits and pieces, what to put where, and so on. Right? And on the other side, it provides us the possibility to innovate centrally. Right? We can update this and make it available to development teams without them doing a lot. And maybe you've read the book of Manuel Pais about team topologies. We significantly also impact a reduction of the team cognitive load. Right? The team can focus on the important things, application development, and not about continuous delivery, building cycle, and so on, and the like, too much. For sure, there needs to be some thoughts about it. On the other side, that's essentially the link to DORA again. We value a lot team autonomy. And the team should own the pipeline in the end, right? We just support the team to have a ready-made pipeline, but in the end, the team owns the pipeline. That means the team needs to have a possibility which parts of the pipeline to switch on, to switch off, to shape the individual steps, what kind of configuration you want to have, where do you want to deploy, for example, which landscape you want to deploy, which tests you want to execute, and the like. That's done in the config file, which is a YAML file. If that's not enough for the team, it's also possible to do some stage extensions. That means, again, team owned. If a stage out of the ready-made pipeline doesn't fit, the team can just extend it or even replace it. Right? That's in the autonomy of the team. The team can decide to do that. Now let's look at the configuration. I mentioned we value a lot the separation of the flow and the configuration. And I believe that's a very important thing, especially when you want to scale. If you just have one repository and everything is in one place, that might be very convenient, and it doesn't harm. Once you start to have multiple repositories, maybe you have a microservice infrastructure with multiple services distributed into various repositories, and you want to share certain information, it will be a nightmare to have the configuration in every single repository. You're always after syncing the stuff. Maybe in one repository it changed, you forgot to change it in another repository as well. And I guess that's where this common configuration layer really shows off, right? The configuration consists of several layers. We do have what we call the Piper library defaults, right? The steps, they come with some default configuration, right? The best known good, you could say. On top, we provide the possibility, again, team autonomy, for teams to add default configuration, which can be shared across repositories. That means teams will put their configuration, which is not repository or service specific, but which can be shared across various services, various repositories, and so on. Then you would have this config YAML. It's located in .pipeline/config YAML. That's the file I showed before, right? That's a repository-specific configuration where you can define a general configuration. There are several sections. There's the section for general, for steps, for stages. It means the general section applies to everything, to every step in the whole pipeline flow. The stage configuration applies only to the individual stages, and the step configuration for sure only applies to the individual steps in the pipeline. Therefore, you have a very fine-grained possibility how you can shape it. And last but not least, for sure you can just pass parameters to the individual steps, which I wouldn't recommend, because then you're back in this very specific, you bundle the flow with a configuration thing, right? Might be suitable for certain cases, for sure. When you think about scale, having more teams, more repository, and so on, that's typically not the best idea to do, unless it's always the same and you know it will not change. Now let's look into a concrete example. One very common example, prominent example, is that you want to version your artifact, right? And there's various possibilities. A library you typically version different than a cloud service. For a cloud service, a SaaS application, typically the version doesn't really matter, at least not to the end user. For the development team, for sure it does, because at some point in time you may need to see what's running. You had an incident, you have an issue, check back with the source code. Now, how can you do that? There's a step in Piper called artifact repair version, and with some extensive configuration possibilities. The simplest thing to do is like you see here. You define a build tool, in this case Maven, and you want to have a short commit ID, because by default this step would create a long commit ID. And the default configuration is rather cloud-like versioning. It's major minor patch out of your build descriptor, adding a timestamp and then a commit ID. Therefore, you can very simply identify when was this artifact created, what's the reference to the source. As said, not always necessary. But you don't need to think about logic to implement it. In the end, you just say artifact repair version. If you don't configure it explicitly, it will just take the long commit ID and you don't need to do anything. If you want to have a versioning for a library, which is rather the semware versioning, typically major minor patch, again, you can define the build tool, npm, and you say versioning type is library, and that's it, right? And then the versioning is like that. Now, I said we started off with Jenkins, and the script I showed before was also Jenkins for the ready-made pipeline. In 2018, Kosuke, I guess most of you know him, is the creator of Jenkins. In 2018, he was CTO of CloudBees, a company doing a lot of work in Jenkins, also providing commercial offerings on Jenkins, and doing a lot of excellent contributions to the project. And he wrote this blog and said that he believes that Jenkins is kind of trapped in a local optimum, right? It doesn't really fit to what is required in a cloud native context, right? If you're familiar with Jenkins, it's essentially impossible to set it up in a 100% high availability manner. For many teams, it doesn't really matter, right? But for larger scale, you may run into this topic at some point in time. And they were thinking about some cloud. Maybe there will be a cloud native Jenkins, what have you. And what happened afterwards? Right? In 2019, or 2018 already, Kosuke joined forces with some folks at Google, brought other people on board, other companies on board, SAP as well, and the Continuous Delivery Foundation was established. It belongs to the Linux Foundation as the Cloud Native Computing Foundation. And the CDF mission is to improve the world's capacity to deliver software with security and speed. Therefore, strong focus on software delivery, continuous delivery, CI/CD, how people call it. Very strong focus there. If you look at the structure of Continuous Delivery Foundation, there's various interest groups. Interest group for interoperability, where I'm also a member of. There's a special interest group around security, software supply chain, bill of materials, machine learning ops. Just recently, a new special interest group was established about eventing and continuous delivery and so on. There's a lot of very interesting things happening. The Continuous Delivery Foundation started off with 3 projects, which was Jenkins. We talked about that. Jenkins X, which is a Jenkins system on Kubernetes, and Spinnaker. Spinnaker was open sourced, I believe, by Netflix, and Google has also a big stake in it. And just recently, a 4th project joined, which is called Ortelius. Now, is that everything? No. There's definitely more, right? There's not, essentially every cloud provider provides its own kind of orchestrator solution, CI/CD solution in their offering. We have Microsoft with Azure DevOps. They bought GitHub. On GitHub Actions is extremely popular, and that's not part of the Continuous Delivery Foundation. Therefore, there's continuous delivery systems within the foundation and also outside, right? And now, how to deal with it? Within SAP, and I believe that's relevant for many of you in the end, scale is important, right? We don't have one single team, one single service. It's typically multiple teams, multiple service, and there is some scaling questions. What we're doing with the ready-made pipelines and what we offer for customers, partners, and everybody of you to join the open source project, what we offer there is, you could say, kind of a paved road. Paved road principle we have not, it's not invented by us. This picture many people use. Netflix explicitly, if you look for Netflix talks, there's very often mention of the paved road for development. In the end, what's the paved road? The paved road is you want to provide something which kind of fits 80% of the use cases, but you don't want to lock development teams in. Talking about DORA, elite performers, you want to have autonomous teams. You don't want to lock them in, right? And if there's a necessity from team side to break out or take a detour, that should be possible. And exactly that's what we want to provide. And I showed you that with the extension capabilities, right? A team can decide to write their own extension, customize what's provided centrally. Another possibility, for sure, not the best one, is just take it and go on your own journey. What we rather prefer is take a detour and feed back the information and contribute back to the paved road. That's why we are driving the project as for SAP specifics as inner source and the majority as open source, because we want to learn and bring in learnings from people using it. Right? It's not like we know everything, for sure not. We, as everybody, we all make mistakes, and we need to iteratively and ideally collaboratively move forward and learn. And that's why we believe a lot in open source. And maybe you haven't seen SAP as a big contributor in open source, but that's really not really the case. If you check, there's various open source projects provided from within the SAP organization. In the Kubernetes environment, you find Gardener, for example. If you haven't heard about it, just have a look. Or Kima. They are of excellent help if you're in a Kubernetes infrastructure. Now, coming back to the topic, what do? We want to, I said we started off with Jenkins, right? We have the ready-made pipelines, we have a step library, we have this common configuration layer. We want to provide scale, right? We want to make it easy for development teams, and the environment is changing. That's no longer Jenkins only, which used to have a market share around about 70%, people said. But as mentioned, the market is evolving. We are looking more into cloud-native solutions, possibly proprietary solutions, and so on. Therefore, we opened up Project Piper in a way that we started to decouple ourselves from Jenkins about almost 2 years back, and make the functionality available to other orchestrators for GitHub Actions. I'll show you that in a minute. Also soon for Tecton or whatever is there. How do we do that? Essentially, the step library has been moved from a Jenkins proprietary thing, which essentially, if you know Jenkins, was kind of a Jenkins shared library, using the Jenkins pipelines as code approach, and we moved that out into a binary. Right? The step library today essentially is just a binary. It's still wrapped in Jenkins, but the Jenkins steps just call this binary, as we can do that from GitHub Actions or from wherever. Now, what is this? How does this look like? Let's take the versioning example again, right? And that's where we move into this infrastructure-agnostic continuous delivery, I call it. Because we have this configuration file. I showed you the configuration hierarchy where you can have, where we have the SAP, where we have the library defaults, where we have the custom defaults, where teams can add their common shared configuration, project-specific configuration, and so on. Right? We have this config file. You see an extract here. In this case, we have a general configuration for a build tool npm. It's an npm project. Now, there's some new things which I haven't talked about. If you want to aim to share across infrastructures, a very important topic is credentials. Right? Typically, inside your pipeline flow, inside your continuous delivery flow, you need some kind of credentials. And we move them into Vault, into a neutral place. In the past, we had them in Jenkins. You could have them directly in GitHub, in Azure DevOps, in Tecton, in your Kubernetes cluster, wherever, right? But then you have to move it all over, keep it in sync, and so on. Therefore, we introduced Vault. That means in your config file, you can refer to a Vault path, a Vault namespace, a server URL, where your credentials are stored. That's relevant for all orchestrators. There's one thing which you need orchestrator specific still, is the tokens to access Vault, right? And for Jenkins, you would put that as a reference to a credential ID into the configuration file. For other orchestrators, we'll see that in a minute, how you do that. Taking the versioning example, again, you would have a step artifact prepare version, and we want to have the short commit ID set. Now we have a configuration file. And taking this into an infrastructure agnostic approach means we want to have this configured once, and we want to use it kind of everywhere. Now, how do we do that? Let's start with Jenkins, the still typical use case where we started off. If you don't use a ready-made pipeline, just use the Jenkins step library. You refer to the piper library. You do some checkout and versioning. That means, first of all, you should clean up your workspace. I've seen a ton of issues for teams not doing that. And then you check out your repository, and then you do the versioning. Nothing specific, config specific in here, right? That just takes this configuration. And now you're working on a local development desktop, right? You do have a shell. Now you can do exactly the same. You can set the app role ID, the app role secret ID for Piper as an environment variable. That would be the typical way how you do that for non-Jenkins. You define these, you fill these environment variables with the secrets, then you clone the repository, you execute Piper with a step artifact prepare version, and it's doing exactly the same as this one, since your configuration is there. Now, talking about GitHub Actions. There's a Piper GitHub action available, Project Piper Action, on github.com. That means if you want to use the same now in a GitHub action, the action script would look like that. You have some environment variables which you preset based on secrets defined on GitHub. Right? We have this Vault app role ID or secret ID that's defined inside GitHub. We provision that into the environment variables. We define, in this case, it's self-hosted runner. It could be also a hosted runner. We do a checkout using the standard checkout action, and then you do a versioning with the SAP Project Piper action. Version master in this case, you could leave that as well. Then we'll just take a default and the command artifact prepare version. That means exactly the same behavior on various systems. Now, what does this give you? when it comes to benefits. First of all, for sure, you could start distributing load. You could start looking into a migration path for your CD environment, right? You may want to use certain runners for certain actions, like you could run certain things still using Jenkins, but on the other side leverage GitHub Actions for other tasks. In addition, you maybe want to shift left certain things, and you could even run Piper on a local development machine to do certain things already locally and identify things earlier. Right? Therefore, you can distribute it all over. I mentioned Tekton. That's currently work in progress. Therefore, nothing I can share at the moment. We have initial tasks running, executing Piper. In the end, you could do it yourself. Take a Tekton task. You have to download the Piper binary and put it into a container so far. We don't distribute Piper as a container yet. This will happen. Once you have this, it's very trivial to define a task in Tekton and just execute the individual Piper steps. Okay, what's next? I showed you the common configuration layer, right? You can configure once and run it anywhere, essentially. That's checked. The step library, the majority of steps is by now available via this binary. There's still some smaller steps missing, which is only available on Jenkins. We're working on that. But since we have the majority over, we can consider this checked as well. The open thing, though, is the ready-made pipelines. That's something we're currently working on to see how we can bring this central definition, which today is essentially a Jenkins library step, defining a Jenkins pipeline centrally, how we can bring this to other orchestrators. One thing we're looking at is how Jenkins X does it, how Tekton, what the capabilities of Tekton are, but we're still investigating here. That's something which is really coming up next. Having said that, I'm finished, and I would open up for questions and answers. And if you're interested, just have a look at Project Piper Elle. Thanks very much for listening, and we should have now enough time for your questions. And just please use the Q&A tool. I don't see any questions coming in yet. Anything you would be interested? Okay, thanks, Dennis. Are there any other infrastructure-agnostic CD project? If so, can you compare them? I have to admit that I haven't seen a lot, or I don't know any of those. Right? The projects I know are rather their own infrastructure. Right? You have Tekton, which is on the rise. There's a lot of effort going into Tekton, for example. I know Jenkins X is reusing a lot of what's happening in Tekton, therefore also sharing things. But still, I haven't seen anything yet where you really have this extreme separation of a configuration and a flow. Tekton goes into it a bit using the task definition and pipeline definition, and on the other side, the pipeline runs and the task runs, which come with a config essentially. But I haven't seen this harsh separation in other projects. Maybe some of you have some. I would be interested in seeing. Maybe you have a project in mind which you would consider as a infrastructure agnostic continuous delivery project. Hope this answered your question. Any more questions? Then I have a question. What are the CI/CD systems you're using? Just type in the name into the chat and use a thumb up for voting if you use the same one. You can, or I just put LinkedIn's and just put thumbs up if you're using that. And just add if you have others. Okay, yeah, Jenkins numbers go up still, right? Andreas, thanks for your question. What about combining infra deployments like S3 and containers, say Helm? Very good question. We do have a step in Piper to trigger Helm deployments. Deployments is an important topic we're currently looking into, and also setting up infrastructure. Therefore, we do have capabilities to trigger Terraform, for example, for infrastructure setup. We do have a step to trigger Helm, and we are currently also intensively looking into GitOps principles. Right? We do have a step in Piper which essentially updates another repository with a container version, for example, that a GitOps tool like Argo or Flux can pick up the change and perform the deployment. Therefore, we are intensively looking also into kind of decoupling the pipeline runs from the deployments, because we see, especially in large environments, where you need to deploy to multiple landscapes, deploying out of a pipeline doesn't make out of the continuous delivery, continuous integration, continuous delivery pipeline doesn't make too much sense, because you would then need to add all the infrastructure complexity into your pipeline and deploy here, there, and everywhere. That's why we're looking for those more complex scenarios into a decoupling. And for Kubernetes, we for sure look very intensively into GitOps. And as mentioned, we do have this GitOps step already available, which allows this decoupling. Hope this answers your question, Andreas. Any more questions? I guess we also then are approaching the end. I think 4 minutes left. Any last questions? If you have follow-up questions, reach out to me on LinkedIn, for example. If you have questions to the project, or also reach out to me, or just drop by on the GitHub page, on the GitHub repository. We're always looking for contributors for sure. There's an extensive development MD available if you try to get your hands dirty. Therefore, just have a look. Okay, and yeah, Jenkins, GitHub Actions, Tecton. Seems like Jenkins still wins, right? But GitHub Actions is getting traction. That's what we see as well. And Tecton will possibly also be the rising star there. Okay, then if there are no more questions, I would close the session. Thank you very much for joining. Enjoy the rest of the conference, and take care and stay healthy. Bye-bye.